Yeah, let's get going. And actually, I apologize. This is really my first online presentation. I've done some video links with my doctors and doctor's appointments, but as far as an online forum, this is really my first. And I do want to say that I retired in right before COVID, and then my institution went towards hybrid and online learning, and I was very opposed to it. Part of the dynamics that worked very well in the classroom were having the students all show up. One of the criteria that was extremely important as part of the learning was to have the students all interacting together. That wasn't my idea. I'm not that smart of a guy. It was really industry that came to us. We had a wonderful industry advisory committee to help basically navigate the program. And especially Boeing aircraft, they said, you know, Mr. Gryniuk, Professor Gryniuk, you're delivering a wonderful student, a wonderful graduate, but they don't get along well with others in the sandbox, you know, meaning they weren't interacting well with a lot of teams. So all of the significant things that take place in technology don't involve one smart individual. It involves a team. So teamwork is essential. And in my classroom, I really made that paramount. As a matter of fact, that was actually part of students' grades at the end of the quarter. And they actually evaluated each other, that who was participating well and who was just along for the ride. So with that being said, again, hopefully you could bear with me on this online format because it's totally new to me. So anyway, with that, let's get started here, and let me know if my screen share doesn't work. Can everybody see that okay? I don't hear anyone. Can you hear me? Okay, yes, good. I got the comments. Excellent, thank you. Like I said, I'm new to this. Let me go back here and launch this. So I want to give you my background a little bit because it's kind of funny how it led me here. I grew up in New England, that's in the northeastern United States. I was in a family. I had two older sisters, a younger brother, my mom and dad. My father was a World War II veteran who saw heavy combat in Europe, in Italy, in France, and he never talked a whole lot about it, but it kind of set a standard for me as far as the opportunity to serve my country that obviously came into play later. My personality, I was like most least likely to survive in my class because all as I was doing was goofing around and making trouble and going to the principal's office, and I really didn't have a lot of focus. Classmates that I'm still in touch with over all of these years, I beg for atonement with them because, again, I look at it as that I did really nothing productive in school. One of my interests early on was aviation. I always dreamt of flying and being a pilot, and even when I was young outside playing and an airplane would go over, I'd look to it. Occasionally, my father's work brought us to having to go to the airport to drop off an item for air freight. This is before UPS and DHL all existed, so you would actually go to the airport and drop it off, and we would sit and watch airplanes land, and I said, I really want to do that. But my parents were not very encouraging because I was a goofball. I just wasn't taking anything serious. And they said, oh, if you want to be a pilot, you need to take mathematics seriously. So anyway, when I graduated high school, I really didn't have any direction. So my final year of high school, I actually signed up to join the US Navy, and I had to volunteer for submarine duty. And one of the reasons that I volunteered for submarine duty is that growing up in Connecticut, it's basically the world capital of submarining for the United States in Groton, Connecticut. And I always remember whenever we were going to the beach and we were going over the big bridge on Interstate 95, my dad would say, you know, boy, keep your eyes open. If you're lucky, you might see a submarine. So they were always in the news, and they were very elusive and, painted black, no numbers on them. And I said, yeah, that's what I want to do. So I went into the Navy, and I went through basic training in San Diego, California. And then I started my first electronics class. Well, I had 4 years of high school electronics, so I still was pretty good at electronics. And basically, I started goofing off. It was a self-paced course. So if you're familiar with San Diego, it's got pretty girls, beaches, palm trees, and I was not focusing very much on the electronics. So I ended up failing a test. And a senior chief took me for a walk on a fire escape, and he pointed out to me, he said, "Sailor, can you identify that vessel?" And he's pointing out in the bay. And I said, "Senior Chief, that looks like an aircraft carrier." And he said, "Son, let me tell you about those aircraft carriers. They need paint. So you could spend the next 6 years of your life painting that aircraft carrier, or you could exceed at advanced electronics, which you're destined for." And for me, it was like a moment from heaven that I finally got it, that the harder I work, the better jobs I'm going to get. And at that point, I took a vow to myself to do the best in any Navy school that they gave me, and my career just really started to take off. So I got assigned to, I actually was given an option. Instead of going to electronics school, they pulled me aside because I was doing good at school at this point, and they asked me if I wanted to go to electronic warfare crypto school. So I elected to do that. It was a longer pipeline. And at that point, I went through that program, and then I went to Groton, Connecticut. Basically, I was in 2.5 years of school before I even saw a nuclear submarine. Once I got assigned to my first submarine, it was about another year that I had to qualify for. So 3.5 years of my life, I did absolutely nothing productive other than go to school and learn the systems. I had a wonderful career in the US submarine force. I was on attack submarines. And again, my specialty was electronic surveillance. And basically, my job description was to exploit any signal from DC to daylight. So I was given equipment that, it was a $16 million system that I was able to use to assess the electromagnetic atmosphere and find out whether what I was intercepting was something that we currently knew about, or whether it was new technology that we needed to figure out how to exploit. So we did this in a lot of locations that were very close to our adversaries. They wouldn't even know that we were operating there. Or if our adversaries were conducting an exercise at sea, we would typically like to get right in the middle of it so that we could intercept telemetry and signals and communication. And again, it was a great job. Everything that I did was top secret. I couldn't talk to my family or anybody about it, but it was great. After I got out of the military, I actually was separated from the military on a medical retirement. I had 3 bad injuries while I was on submarine, and that led me to my final duty station was teaching for the Navy. So once I left active duty, I thought it was a natural fit for me to become a teacher. And little did I realize that I ultimately would continue my education to become a professor. On top of that, I don't only consider myself a professor. Part of the success of my program and the success of my curriculum was that I was a collaborator. I would never sit in my office and just come up with a curriculum. I would always collaborate with industry and say, what exactly is it that you need from me? If I produce these graduates, will you hire them? What is it? What qualities are you looking for? And basically, at that point, my program really started to take off, and enrollment skyrocketed. My graduates were all spoken for before they even graduated the program. It became highly successful. My final accomplishment while teaching was our institution. Our first National Science Foundation grant was a grant that I put together, and I was the principal investigator of it, and it was on photonics. And I don't know how many of you are aware of photonics, but it's kind of it's light energy. the behavior of photons. Of course, electronics is the behavior of electrons. Photonics is the behavior of photons. So this is the next new big thing. And photonics are already being used in a variety of applications. Everything from warships have high-power lasers now to go after drones, to medical devices. Eventually, computing will get there where you're using light energy that travels at the speed of light, right? And it just makes a lot more sense. So that was my final accomplishment before I retired. So that's kind of my background, where I'm coming from. Again, my personal interests at this point: electronics, mechanics. Every vehicle that I've ever owned, I've always learned to work on it myself. I don't bring my car to a mechanic. I get the manuals and I learn to do it myself. Aviation was a big interest of mine. I became a pilot in 1985 and had a great time flying. I retired from flying in 2022. I enjoy, again, following military. I have a lot of friends that retired from the military now, and like staying plugged in with that community and keeping abreast of all technological advances. My wife and I enjoy travel. And speaking of travel, I've been to Amsterdam numerous times. My youngest son went to work. It was actually funny. I refused to pay for my children's college because, as a professor, I saw students that somebody else was paying and they just weren't engaged. So our youngest son, he worked his way through college working for Delta Airlines, and of course they fly to Amsterdam a lot. So if they had empty seats, my wife and I were on a flight to Amsterdam. And one of my fondest memories was going to a local pub, and one of your football teams was playing. And anyway, once they found out I was American and I was a good guy, I could not buy a beer. They kept buying me beers, and it was a great team or a great game. And the local team won, so they were all very excited, but I couldn't buy myself a beer, and really appreciated the hospitality that my wife and I received while in Amsterdam. Like spending time with my family, friends, and to this day, I enjoy networking, and a lot of you have heard that term. And don't think of it as a bad term. I'm out networking. It makes it sound like, you're doing it for ill purposes. I truly believe that every person that God puts in my path, God puts in my path for a reason, and it's my reason to figure it out. So if you and I are seated next to each other on an airplane and we start talking, I figure there's a reason behind this, and that really has allowed my network to explode. And you probably can't pick a topic on anything that I don't know somebody that I can't call and get the straight information from. So networking has been extremely important and still is, even for me in my retirement. What I'm going to talk about today is the tree, as I call it, the tree of electronics. And the tree of electronics really explains everything to me. And when I'm done with this, it should kind of explain everything to you. The roots of the tree of electronics, everything that ever has been done and will be done with electronics, is rooted in 4 properties.
Professor, sorry for interrupting real quick.
No problem.
There's this small button on, it's called hide, is written on it. If you press that, It would be a bit better. Yeah, thank you.
I pressed it and nothing happened.
No, it's already perfect like this. It's perfect.
Okay.
Yes. It
Okay.
was just for the screen recording. Yeah. Thank you.
Oh, okay. I'm sorry.
Awesome.
Yep. Thank you.
Continue. Yes.
Thanks for keeping me honest. So, as I was saying, everything that's ever been done with electronics or electricity or that will be done is based on these 4 properties. So if I were you, I would really learn as much about these 4 properties as you possibly can. It's current, which you're all familiar with, voltage, resistance, and power. Now, mathematically, we manipulate these 4 properties with 2 laws. And these are not laws that you could go and have legislation change. These are laws of physics. They can't be changed. And there's really two laws that govern the behavior of these four properties. And it is Ohm's law and Watt's law. And as you see on the left side of the screen, these are all of the algebraic variations of manipulating these four properties. So if you know that, and you're an engineer, on paper, you can predict the behavior of these four properties. Now, if you physically want to manipulate these four properties, you're going to need to use what are called, of course, electronic components or discrete components, and we're going to use circuits to manipulate those properties. The first component, and we're going to go through this very, very quickly, because again, this could go on I could go on for a week just talking about components. But we have fixed components, resistors that are fixed, either carbon wound composition chip metal film. We could have resistive networks that are primarily surface mount technology. We have thermistors, and as the name gives away, thermistor is a thermal variable resistor. And then we have variable resistors that we could use for operator input, such as rheostats, potentiometers, and trimmers. We have capacitors. Capacitors store energy. They could be fixed. Ceramic, electrolytic, paper film, glass, mica. We could have variable capacitors that typically are used in old radios for tuning the radio, but variable capacitors still are in use in a lot of contemporary electronics. Another variety of components that we use to manipulate those four properties are transformers. Could be AF, which stands for audio frequency, RF, radio frequency, or power transformers that you would find actually converting one type of energy coming out of your wall to a type of energy that you could use inside the internal circuits in your equipment. We have inductors, yokes, flybacks, relays, solid-state relays, time delay relays. One of the big advancements that's taken place in the past 30 years is the use of transducers. Transducers could measure flow, fluid level, motion, pressure, temperature, vibration. Actually, a lot of the new construction, the architectural standards, especially here in the west coast of the United States, when they build a high-rise building, they will put various vibration transducers in the building, and if we have an earthquake, basically they go to a box or a computer screen and look, and basically the building inspects itself and says, yeah, it gives you a green light, the building is okay to enter, instead of having to have physical engineers. Actually, even using strain gauges, which actually measure strain. Boeing aircraft locally has embedded strain gauges in their aircraft, so if they encounter severe turbulence, that basically could tell the computer, hey, you need to land and have maintenance take a look at this, or no, this was well within our specifications. So transducers, especially if you own a contemporary automobile, transducers are just everywhere. And then finally, we have to have a way of us humans interfacing with these components. And these could be dual inline switches. They could be keyboards, which you all as hackers are familiar with. They could be lighted, push button, rotary slide, snap action, thumb wheel toggle, any way that allows us as human beings to intervene with the individual components. Of course, electron tubes, a lot of people think electron tubes are dead. They're still out there. Cathode ray tubes, special purpose tubes, which include gas vapor klystrons, imaging tubes, sensing tubes. If any of you are familiar with FLIR or infrared night vision, of course, that's all brought to us by a specialty tube. TV picture tubes, computer monitors, of course, now most of us have gone for flat screen, but still in commercial television broadcast, picture tubes are still used in a lot of the applications. Then we move into the whole category of components that really didn't exist up until about 60 years ago, and that includes discrete semiconductors, diodes, protection devices, thyristors, transistors, custom integrated circuits, linear memories, which include RAM, ROM, CMOS, EEPROMs, which I'm sure, again, a lot of you are very familiar with as being computer folks. And also the price of RAM has gone through the roof. I was just reading an article that a local retailer is having to pull the RAM from their display models because people are getting into the cases and stealing the RAM because it's so expensive. Microprocessors, bipolar CMOS and MOS, and logic families, bipolar and MOS. And then we get into the whole array of optoelectric devices, laser diodes, light-emitting diodes, optocouplers, photoconductive cells, photodiodes, phototransistors, photovoltaic cells. And I'm sure a lot of you are sitting there, where's he going with this? Just bear with me. In addition to the components, we also have to have a way of connecting our components together. And it's very important for you to learn a lot of these systems if you're going to get hands-on with the equipment. And this includes coaxial, cylindrical, fiber optic connections. I mean, if you could learn how to splice fiber, that's a skill set that you're going to have with you for the rest of your life. Flat cable, insulation displacement, PC edge connectors, rack and panel. So all of these different interconnects have their pros and cons, and all of these interconnects also have their limitations as to what their applications can be. If you have an ejection seat on a fighter jet, I don't think you really want to have it plug and play, because if it's plug and play and it becomes unplugged when the fighter pilot wants to egress the aircraft and eject, maybe it's not going to work. So there's electronic standards that govern which type of connectors are going to be used in what type of applications. And then we get into the category of miscellaneous. This includes antennas, crystals, character displays, printed circuits, chip carriers, and interconnections like backplane on a mainframe computer. Now, where I'm going with all of this is this next level up the trunk of the tree. Again, as a refresher, if we want to manipulate mathematically the four properties of electronics, we do it utilizing Ohm's law and Watt's law. If we physically want to change the characteristics of any of these four properties, we could use electronic components. If we want to physically do something with these components and change the characteristics, we need to use what's called an electronic circuit. Now, there are thousands and thousands of components, but literally there are only really hundreds, if even, of circuits. So once you study circuits and you understand one type, you understand at least how the others are put together. And this includes signal generators and timers. And again, any of you with any experience in computing know that timing is everything, when it comes to operating a computer. It could be sine wave generators, it could be oscillators, square and pulse generators, which there are a number of in computer circuitry, ramp and triangular wave generators. Power supplies, you can't have an electronic piece of equipment without a power supply. It could either be a switching power supply, which of course is most popular. Your desktop computers all have switching power supplies. Could be a linear power supply, which is more commonly found in some of your consumer-grade electronics, or, of course, uninterruptible power supplies that, in the event of a power failure, will automatically switch up to a backup. We have digital circuits, gates, flip-flops, display drivers, counters, dividers, encoders, memories, input-output, microprocessors, latches, registers, multiplexers, demultiplexers. These are all the different types of circuits that go together into making a device. Amplifiers, bipolar, could be FETs or field effect transistors, or most commonly now we use a lot of operational amps or op amps. Miscellaneous detectors, filters, phase lock loops, converters, data acquisition, and synthesizers. So, as a refresher, again, the four properties mathematically manipulated with laws, physically manipulated with the components. The components are put together in circuits, and the circuits are put together into systems. And as I would tell a lot of my students when I entered the program, you're going to have to figure out what type of branch of electronics that you're going to want to get into. You can't be a generalist. You cannot become a specialist in all of these applications. You need to become a specialist in one of these applications. And as I used to tell my students, if you've ever climbed a tree, What happens when you get out on a limb? When you get out on a limb, the limb starts to get weak and it could break off and you could fall from the tree. Well, it's the same thing in technology. You need to become a specialist and go way out on a limb, and that's where you're going to make a lot of money. That's when you're going to have a lot of success. But chances are that limb could break, and when the limb starts to break, you need to scurry back to the trunk of the tree and figure out where you're going to go from there. I've had a couple times in my career that has happened. But the branches are all broken down into really these discrete categories: communication, data processing, consumer, industrial, test and measurement, and biomedical. Television, of course, covers broadcast television. It could be closed network television, as in CATV or cable TV, which also includes any satellite providers. Or, of course, it could be CCTV, primarily used in security applications. But there's connectivity between all of these branches. Then we move to communications. This could be concentrators, front-end communication, message switching systems, modems, multiplexers, network controllers, and mixed service, which, again, probably a lot of understand, combining voice, data, video, and imaging. This is like my local internet provider provides all of these things on one cable coming to my home. Telecommunications, switching systems, data, voice only, cellular, telephones, which telephony still has applications. It's still a very, very reliable form of communications. Telephone, video equipment. Also under this realm is radio, which includes amateur radio, which is a great hobby to get into if you're interested in playing around with electronics and manipulating electronics. And there are a number of local groups that you could join to advance that. Aviation, electronics, communication, broadcast equipment, land mobile, marine, microwave, satellite systems. I mean, it's a huge industry, communication. Still have facsimile terminals, radar and sonar systems, and fiber optics. Now we get into an area that all of you, from a hacker standpoint, are interested in. This is data processing. So believe it or not, at the end of the day, everything that you do and every system that you try to hack is really under the realm of data processing. And data processing, of course, has I/O, input-output. Is this computer microfilm? Is it a digitizer? Is it a graphics tablet? Is it a light pen, trackball, optical standing device, plotter, printer, which of course could be impact, laser, thermal, inkjet, laser jet, electrostatic. There's a variety of different printers for your I/O operations. Data terminals, still in some military applications, include CRT terminals, ASCII terminals, graphic terminals, color, monochrome, remote batch entry terminals, and then computer systems. Microcomputers, mini computers, personal computers, technical workshops, multi-user stations, mainframe computers, and all the way through supercomputers. Data storage devices, you're all aware of: fixed, flexible, optical, still cassette, cartridge, still used in some applications, legacy equipment, and reel-to-reel magnetic tape drives. Now we go into consumer, but don't forget about data processing. I'm not forgetting who my audience is. We're going to come back to data processing here in a bit. Consumer electronics, audio equipment, phonographs, records, music players. Actually, consumer electronics is my least favorite because it is very cheap quality. Even if you go out and expend the most money on the most expensive system, whether it be audio or video, it's still consumer-grade electronics. It's kind of garbage electronics, and most of the stuff really is not repairable. Personal cameras, watches. Of course, we have wearables now. You know, you can go out and get a wearable that monitors your health, and then you download it regularly. Telephone answering equipment. in addition to systems that actually call out, and I'm sure you've all had that experience in the Netherlands as we have it here in the United States, where I get a phone call and it's a computer calling me. And then I answer it, and then there's a couple second pause, and they connect me with somebody that's trying to sell me something I don't need. Personal computers, microwave ovens, music equipment, pacemakers, hearing aids, alarms, smoke detectors, video equipment, projection TVs. I mean, you get the gist of video consumer equipment. Also involved in consumer equipment, believe it or not, it's the most reliable form of consumer electronics is automobile electronics. They're manufactured a little bit to a higher standard. Of course, they're non-repairable. The companies, manufacturers, make sure you can't do that. That also includes navigation systems, car alarms, mobile telephones. Now we get into industrial systems. Industrial is actually one of my favorites because when you're working on industrial electronic systems, they always provide you with maintenance manuals that are very, very detailed. And then typically whenever a company buys an industrial system, they not only buy the equipment, but they also buy the technical support or the logistics support, meaning that you get a catalog with part numbers, and then there's inventory that will actually be held at your place of business. So if something malfunctions and the equipment is offline, you could order the part, and whoever your parts people are at your organization will go find the part for you and literally put it in your hands within minutes. So these are very robust systems, could be energy management, inspection, motor controllers, numeric control systems that, again, could be used for numeric control milling operations, manufacturing processes, process control equipment, robotic systems, and vision systems that are way better at inspecting a product than our human eye is. So these are very, very popular systems. Computer-aided design, CAD, and computer-aided manufacturing. Design software, of course, there have been a lot of great advancements. And that's one of the things that my program actually got in down at the bottom, printed circuit board design. If you're going to build a circuit or a system, you have to put it on a printed circuit board. That's still how we do business, and those circuit boards need to be designed. So it's really a nice niche market. Industrial systems include management systems, computers, typewriters, calculators, copiers, telephones. Automated test equipment is the next category. And this is anything that will test a device. These are very, very critical in industry to allow rapid manufacturing of systems. And then general and test equipment. These are all the pieces of equipment that we use to measure all of the parameters that we encounter while manufacturing any of the aforementioned equipment. If you're going to test equipment, you need signal generators, audio generators, oscilloscopes, RF microwave generators, analyzers, circuit emulators, temperature measuring equipment, noise measuring equipment, recorders, plotters. It's really a whole subsection of the industry unto itself. If any of you are familiar with Fluke Corporation is located out here in my neighborhood. They're just north of us in Everett, Washington. And, Fluke is basically the world leader in the manufacturing of general test and measurement equipment. Then we finally get into biomedical, patient care, surgical equipment, monitoring equipment. If you've ever had the unfortunate opportunity to go to a hospital lately, it's all electronics. Actually, some of the monitoring of patients now is even outsourced. It's put on the network, and you've got somebody sitting in a dark room across the country monitoring a patient's metrics, via the biometric equipment. Diagnostic, they continue to come up with new fancy ways of measuring inside us, again, from the most simple X-ray to MRI, EKG, EEG, clinical, centrifuge incubators used in laboratory testing for biomedical. Finally, we go to the history of electronics, and I don't want to turn this into a history lesson, but I think it's actually kind of cool. If we cut down the tree of electronic and we start counting the rings, we really go back to like the 1600s, where William Gilbert first understood the properties of magnetism. You move forward through there, and some of the big names we see, Charles de Coulomb basically was able to quantify the movement of electrons inside a conductor. Alexandro Volta first defined the volt. James Watt came up with the correlation of voltage and current as it relates to power. Andre Ampere, the unit of measure, 1 coulomb per second, is an ampere. George Ohm for the property of resistance. Faraday, Henry. I like the one 1887, Heinrich Hertz. He actually discovered the rental car company that is known worldwide. Now, of course, Hertz is the cycles per second, it used to be called, for the use of telecommunications. Guillermo Marconi, the first transatlantic communication. Edison, Tesla. All the back in 1987, where superconductors were defined, and superconductors are still, of course, being developed as we speak. So, how does this apply to you as a hacker? Well, the first thing you need to do is determine what type of a system is it that you're going to hack. Is it a consumer product? Is it data processing? Is it code inside some institution? Do you want to somehow insert bad code into test equipment so that everybody starts getting the wrong readings? If you are nefarious, do you want to infect some biomedical piece of equipment? The thing that you need to understand is that no matter what system it is that you're trying to hack, that hack is basically, that system is made up of circuits. And as we talked about, those are either analog circuits or digital circuits. Now, if you're going to hack it, obviously it must have a microprocessor or a microcontroller or some means of digital communication that you're going to target. But ultimately, what you want to do is take control of a circuit. And as I said, there's less than 100 types of circuits for you to study. Now, how are those circuits actually, what are they made up of? They're made up of electronic components. So ultimately, if you want to hack a system, you may want to target an individual electronic component. Now, every one of these electronic components has what's called a manufacturer's data sheet. And they're free. The companies put them out for free, and it lists all of the specifications, how these components behave to voltage, current, resistance, and power, and also how they behave to temperature. So let's just say, as an example, you want to hack a device, and that device contains a power supply, and that power supply has thermal regulation in it to basically prevent the system from operating when it's hot. If you could target the thermistor, one of the semiconductor devices that monitors that, and say, hey, if somehow I could manipulate that thermistor, I could shut this power supply, which will render this piece of equipment useless. Well, how can I target that thermistor? Can I hack the thermistor? Well, no, but maybe you could hack the circuit that controls the temperature inside the data processing system. So all of a sudden, when you hack that system, because there's a metric that's used, there's a number that is used, at this temperature, turn the fan on, at this temperature, turn the fan off, at this temperature, increase coolant circulation through the system, at this point, shut it off. If you could target that, then indirectly, you could cause that thermistor to basically give a false reading, or a reading that would precipitate shutting the power supply down, which will render the piece of equipment useless. So it's these indirect hacks that I would encourage you, the deeper that you dig into the tree of electronics and understand the fundamentals of electronics, I think the more effective that you're all going to be in your niche of hacking. And that also includes voltage, your understanding of voltage, current, resistance, and power. I think a lot of you are probably familiar with Stuxnet, and I think there's still some controversy as to who wrote that code, whether it came out of the US or out of Israel. But that was when we targeted the Iranian enrichment facilities in their development of nuclear weapons and nuclear technology. Basically, Stuxnet was it got through their air gap on a USB. That USB was probably dropped in a parking lot outside of one of their facilities, and somebody plugged that USB in to their air gap system, and it got bad code in there. That code targeted PLC systems, programmable logic controller systems. And specifically what they went at was the system that controlled the centrifuge and the speed controller, rendering it inoperable, and basically the centrifuges spun themselves to destruction and destroyed 1/5 of Iran's enrichment capabilities just with bad code. So that's an example of how you could target a component, to target a system, to target a general piece of equipment that's being utilized out there. So anyway, that is my my formal slideshow. Does anyone have any questions for me? If we could open this up now to Q&A. Uh-oh.
Hi, Professor. Can you hear me again? Let me see the audio. Yeah, so I think he left. Yeah, I think he left on accident. I'll see what I can do. Let me see. Ah, no. Let me check. Do you guys still see? Oh, no, I see. Yeah. Professor, we can't hear. The audio, I think, is a bit bad. But we were able to listen to the whole lecture. So everyone in the audience, if you have any specific questions, I'll go a bit back and see if anyone asked something. Let me see. Okay, this is something that got shared. Okay, let me see. Yeah, hello, Professor. Yeah, on Discord we can't hear you anymore. Yeah. Where? Yes. We reached the end of the PowerPoint. I disconnected you from the room. Now I'm inviting you again to speak.
Okay, I'm back with you.
Yeah, perfect.
Turn on camera.
Yeah, we
All
can
right,
hear you.
I'm back. I'm back.
Welcome back, Professor. Awesome, loud and clear now.
Excellent.
So,
Yeah, unfortunately, I was on full screen, so I couldn't see any of your messages. As again, like I said, I'm not used to this platform.
Yeah, so that's not a problem. I'm trying to copy like the questions. Like people were just leaving comments, like started watching your lecture, very much liked your teaching style, stuff like this. And one of our moderators and Discord developer, he also left a message saying to keep the songs going for every guest lecture. This song is for you as a thanks from the community. So these are songs made by AI.
Oh, really?
So this is an AI song dedicated to you.
Okay.
So you could listen to that whenever. And Breach said...
Oh, I'm looking forward to, I don't know if I want. I've gotten myself in a lot of trouble over AI lately, so.
AI is going crazy lately, I'm going to be honest.
Yeah.
And Breach sent a message, where would you start to learn electronics in the context for someone that wants to do web app pen testing? So that's a pretty big jump between, because are there specific electronics that you can target for websites? I think there's a big jump between those, right?
Yeah, and as I spoke with you offline, the number of students that I had that came from um, really high-end programming backgrounds, it was very important for them to start in the beginning to understand all of the basics so that they kind of knew what they were working with. So instead of just working with code, being able to understand the technology of what hardware you're physically working with, so that again, in the test and evaluation phase of software, you kind of know what you're working with. Basically, you can't have the electronic engineers BS you. You know, you basically have some credibility on par with their knowledge level.
Yeah, and also, so that's the point of understanding systems more deeply, so that you can target them more efficiently or in smarter ways. But also, yeah, when you just use a hacking tool and that's it, like you download a hacking tool, you run it, you get some output. That's when people call you a script kiddie. But the thing is, if you understand, the more you understand, the less you are dependent on that tool, because you understand how the attack works, and in the worst case, you can program a tool yourself that does the same thing if the tool wasn't there. But is it the same? Are there many attacks that could target um, the lower level uh, yeah, the lower level layers? Because, for example, there was an attack, I think it was called Spectre, and it targeted the microcode on processors. So at some point, it was basically, if you had this type of processor, um, then you were vulnerable on a very deep level. But are you aware of any vulnerabilities that are, I don't know, on I don't think there will be anything on resistor level or something like that, but on motherboard level, or are there like some certain techniques where you can guess certain data based on the voltage of something? I heard something about that. That
Well, if you look at Volkswagen in the past, they hacked themselves, did they not? To basically meet a United States emission standards.
Yeah.
Basically, what they were doing is the sensors were sensing accurately, but how they programmed the ECUs in the cars to interpret that data was erroneous. So when you would plug it in, it would show that the diesel engine was running efficiently and meeting all environmental criteria. But of course, we learned later on it was not. So that's a specific example of where engineers hacked themselves and did a workaround to make it appear to the authorities that emission standards were within compliance. Again, from a hacker standpoint, there's probably not a lot of reward in hacking an automated coffee maker or a consumer grade product. Unless, again, it's for nefarious purposes. Maybe you're upset with the company and their ethics, and somebody wanted to hack them. And, because anything that, again, is microcontroller controlled or microprocessor controlled, could be hacked. I was shocked. An early version as a pilot, I got an early version of a GPS. It was a Garmin GPS that I saw through its life. And I was in there doing maintenance, and it had a 386 microprocessor inside a handheld GPS unit. So obviously, if you wanted to hack that, and the latest update, when you updated the latest version of firmware and were able to slip some bad code in there, you could basically disrupt the functionality of that GPS unit.
Yeah, that's true. That's where at the end of the day they're running on some type of code.
Yeah,
And
yeah.
the thing is mainly, like, how do we reach it? Like, how can we even talk to it? So obviously, if you go to a website, you can interact with the website. So for many people, that's trivial. But you might think, like, um, the processor itself, can we target that with a certain attack? But it's not gonna be, you're not targeting the hardware. You're gonna be, of course, targeting its input, and
Right.
yeah, you're gonna be targeting its input. That's why you say, like, if you if you attack the firmware, if you can slip firmware, there you can do something with it. Yeah. So
Well, as an
yeah.
example, so let's go back to that Garmin GPS. Basically, Garmin no longer supports that GPS. Okay, it fulfilled its lifelong obligation to it, and then they're not providing updates anymore. If I, for nefarious purposes, and I don't know why I'd want to do this because I don't think this way, but if I wanted to ruin those GPSs or make them non-functional for a lot of people, I could go ahead and write code and then put up on a website, hey, free updates, for this GPS. Well, Garmin doesn't support it anymore, but you get excited thinking all of a sudden it's a free update that some company is offering, and then you load it onto your Garmin GPS, and all of a sudden it locks it up, or it puts you 50 miles, off where you're supposed to be. That would be one example. But you bring up a good point. There has to be a way of getting into it. But now with so many, I digress, but my wife and I, we had a frozen water pipe 2 years ago. It destroyed our home. We lost 80% of our house and our contents. So everything in our home now is new. And I was shocked at, like, every device wants to live online now. So it does automated updates so that with my smartphone, I could communicate. I could tell the first cup of coffee that I had when we moved back into our house, my wife made it from the other side of the house via her app on her phone. So that's a way in. I mean, if everything wants to reside online now, obviously as hackers, you have a way into these devices. And that's very concerning for me, I mean, it's really an open door.
Yeah, that's one of the interesting topics. Um, and Smiley also asked, "Are you familiar with some hardware hacking techniques that you could talk about from your experience?" Because as a professor, I think you look at electronics different than hackers in general. But also, like, hackers usually don't, from what I've seen, usually they don't start there, because a lot of hackers here in the Netherlands, they're trying to get certain certificates to be able to get a job, because it's easier to get jobs in certain types of hacking than in others. So obviously there are IoT and hardware hackers. Also Harker, who is here, he's into that. There was some other guys here as well who are also into that. I think Bensek said he is also currently working in OT, so that's definitely a thing. But I'm pretty sure the way that they look at it might still be different from the way that you look at it. Maybe while you were thinking about it or studying it, you would have seen stuff like, you see something like, oh, if someone had bad intentions, he could easily manipulate this or do something crazy with it. Like, have you had any of those moments?
Again, the only way into a piece of equipment is now, of course, we reflash our BIOS, whether it's a flat screen TV or a piece of test equipment. There's always that update that you have to perform. That's the only way in that I'm familiar with, unless you're working, again, at a company and you're engineering, and for nefarious purposes, you intentionally want to put bad code, into the device. But the real risk happens anytime that device is communicating out or communicating on a network. And with all of these pieces of equipment now that want to be network resident, I just see that as a big security flaw. I actually commented, this has nothing to do with electronics, but it has a lot to do with kind of what we're talking about. So my background in submarining, I'm not divulging any secrets here. We used to go offshore and submerge, and basically nobody knew where we were going or what we were doing. So in a wartime scenario, we were a total wild card. Okay, this article that I was reading online and I commented on basically involved saying, hey, submarine force, you need to get with the program. You need to be part of these data links and communicate with other forces and everything else. I said, absolutely not. That's been our secret sauce. Not being connected to the outside and being totally unpredictable is what really gave us our strength in operation. And you need to look at the same thing. It's applicability to a piece of equipment. If you have a piece of hardware that is sitting in a cabinet and it's not communicating with the outside world, even not communicating via Bluetooth, because of course Bluetooth is a way in. If it doesn't have Bluetooth capability, if it doesn't have to reside on a network, and it's just sitting there, it's almost next to impossible for you to hack that system. But if you provide an update to it, all of a sudden you got to provide an update and online. Get a USB stick and it writes the code on there, and then you stick the USB stick in the back of your piece of test equipment. Now you're vulnerable. But other than that, no, there's no way. And I don't say there's a way you could hack a resistor, but there is a way to hack basically like how a thermal resistor behaves, and that's by changing the environment around it.
Yeah, definitely. The I think one of the things is that the resistor level, etc., is too low, and you're talking about the firmware level. But are you aware of companies that build backdoors on some type of component level, like malicious hardware, basically, with the built-in firmware, or certain drivers that companies maliciously publish, or that they get taken over? Like, are there? Because I remember there was an interview with McAfee, the owner of the McAfee security company, and he was talking a lot about that certain chips and certain components in phones and in computers are inherently, like, they're already backdoored before they even get shipped out to consumers. So have you encountered any
Yeah,
of
and
that?
a lot of companies hold that very near and dear to them, and they won't reveal that. That's been the big concern, quite frankly, with a lot of the off-the-shelf equipment that the military uses, and we have to trace the lineage. Most of the nefarious circuitry for us is coming out of China, where basically you have these circuits that are embedded in a product that could be activated remotely and render them useless. I mean, look at what the Israelis did with the pagers, and a very similar thing. There could be latent circuitry, but most companies are very reluctant to talk about any vulnerabilities that they have, even as far as the loss of MH370, the Boeing 777, Malaysia Air Flight 370. A lot came out with that, saying that, remotely, a lot of the facets of controlling that aircraft could be done nefariously by just having access to the computers that run it. You don't need access physically to the cockpit and the controls. And again, Boeing was very reluctant to talk a lot about that, but I think it clearly came out that there are some capabilities there.
Yeah. Let's read. Let's see if there's any questions. Um, so Breach said the lowest level. Harker is talking about JTAG and UART for connecting to hardware debug ports. I think there was also a question about how to start learning electronics, or what's the most like, is there a way that someone could, like, I see a lot of people talking about the EPS chips and stuff like this, and buying certain hardware or NFC receivers and transmitters, like the Flipper Zero and stuff like this. Is this the ESP32? Is this like a valid way to get closer to IoT and hardware and to start learning more about this level, or should you really start with the theory about the laws that you talked about, or where should you start in order to get like an efficient way to understand more about this for the purpose of hacking?
Yeah, that's a very good question. I don't think you're going to like my answer. And I didn't like my answer when I was a student of electronics. But you really have to start with the basics. You have to start with that understanding of voltage, current, resistance, and power. So a great place to start is, again, I'm not trying to pimp my lectures because there's nothing in it for me. But if you enjoy my teaching style, that is a great place to start because you absolutely positively need to understand that stuff 100%. One of the things that I did when I was teaching is I developed my curriculum that allowed my students to correct themselves to 100%. So any of their homework or lab work, if they made mistakes, I'd allow them to correct their mistakes so I could give them 100% credit for it. Because you can't know 70% of electronics and move to the next stage, and 70% of that and move to the next stage. You have to really have a firm grasp of all of the technology and then be able to advance to the next level. So that being said, starting out in the basics with a basic understanding of voltage, current, resistance, and power, then understanding how these different components react to it, and then understanding how these components are put into circuits, specifically like digital circuits. So if we're talking about registers or input output or shift registers or anything associated with a computing device, whether it be a microcontroller or a microprocessor, you have to understand the original components that put it together. Now, can you understand millions of transistors on a microprocessor? No, but you could understand the circuits that are used to make up a microprocessor, so that when Intel comes out with a new microprocessor and it comes out with a big thick fat book on all of the commands and all of the structures that go with that microprocessor, when it comes to a input output, say, you could go to that chapter and look up and see exactly what changes have taken place. But you're not going to memorize a book like this, but you do want to be able to understand the changes in the circuitry that they have manipulated. So there's really no way around understanding the basics and getting around understanding the basics if you're truly going to understand the technology. Because even that, you could be working on some type of a digital experiment that isn't functioning properly, only to realize that your power supply is insufficient to power the circuitry. So you really gotta go after those basics. And usually that's where I remember when I was in the Navy, I had a system fail when we were on an operation, and it was a $16 million system that failed. And the system was never supposed to fail. It was only supposed to go into a degraded mode. Well, it failed. And I was getting called in by the captain saying, "Hey, Gryniuk, your system's down. Come on, man. This is why we paid millions of dollars to train you." And I stuck with the problem. And basically, the problem always could be solved with an understanding of voltage, current, resistance, and power. I'm not trying to oversimplify it, but really if you don't have that understanding, you can't effectively troubleshoot sophisticated electronics equipment. And usually the simplest solution is usually the solution, if that makes sense.
So basically, going to the basics and understanding it one step at a time, going up into digital circuits, and understanding how the CPU works, like internally with the flip flops and all of that stuff, is probably help you at some point, right? Or
Yep.
or is it too specific, this knowledge? Is it like knowledge that you should only get if you're really trying to design a CPU? Or do you think that understanding it on that level would also benefit you in terms of, I don't know, reverse engineering or coding something or hacking something? Or is it really for...
I think just having that background in electronics is going to make you more successful in life anyway. I mean, if you have an appliance that fails in your home, either, you could have somebody come in and repair it for thousands of dollars, or in a lot of cases, you could fix it yourself. Because again, everything is electrical, everything is electronic now. So having that fundamental understanding is not only going to help you in your professional arena as a software developer or hacker, it's also going to save you a lot of money around the house finding a simple cause as to why a piece of equipment is malfunctioning.
Yeah. Smiley is asking about ICS/power generation, What problems arise from networked power generators, distribution, storage? Yeah, so he's asking about attacks on this. For example, like what type of problems could arise from ICS power generation?
Well versed in that. I really couldn't answer that. Again, if I was from the outside looking in, I would probably go after, the power controls associated with that, if you were trying to exploit that. But yeah, I'm not that familiar with that.
Yeah, me neither, to be honest. So I'll just ask his question. Um, let's see, guys. Do you guys have any questions for Professor Joe, or was that about it? It was very active in the chat, so people are really enjoying, especially the people who are more into this stuff. Um, so Breach is asking, do you have any life advice? That's a more general question.
No, and that's good. That's a good question because that goes back to what I was saying about networking. Um, I try to treat everyone that I meet with dignity and respect. And as I said earlier, I truly believe that the Lord up above is putting that person in my path for a reason. And it's my job is to get that information out of the person and what is the reason that you've been put in my path. And that has come in so handy. If any of you think that you're going to become the subject, if any of you think that you're going to become the man, there's no such thing as becoming the man. You're not going to be the subject matter expert guru. You know what you know, but more importantly, you know what you don't know. And what you don't know, hopefully you have a resource that you could reach out to in a collegiate manner, and for advice, for assistance. I had no problem sharing with my students or colleagues what it is that I don't know. Just say I don't know, but I know a guy that I could call and find out the answer. And that's very, very powerful, and it has served me well. And I think that's been the greatest key to my success is being surrounded by people. I always like to say that I'm the dumbest guy in the room. So if you could put yourself in a room full of really smart people and be the dumbest guy in the room, you're doing something right.
Yeah, definitely. I think it's pretty hard for you to put yourself in a room where you're not one of the smartest. So you'd really be in an impressive room, I think, at that point. So Decoded Finn is asking about triode. He apparently needs to use it in a project, and he doesn't know how to use it or something. So I don't know. That's not really related to hacking. He says that as well, but maybe like a
No, that's a good
pointer.
question, though. But
Yeah.
I would recommend going that specific triode that you're trying to use, get the manufacturer's data sheet on it. And then with the manufacturer's data sheet, they will also include a simple circuit that you can fabricate to test and evaluate that component and see its behavior. So usually all of this is on the components data sheet from the manufacturer. And of course, you're going to need some test equipment to be able to do that. But if you could do that on your bench top and then integrate it in the circuit, you know how the component's going to behave. So believe it or not, that is 99.99% of all of the labs that I used to have my students do were nothing than me stealing the test procedure from a manufacturer's data sheet and having the students perform those tests so they understand how the component is going to work real time.
Awesome. I think that must have answered this question. Uh, and also Harker is confirming that it's one of the first things. He says data sheets are love, are hard.
Absolutely. Absolutely.
Yeah, Professor, I really want to thank you for your time and for answering all of these questions. It was a great honor. It was a very fun time. And one last question from my part is the sheets, because it was a very interesting sheets. Would you mind sharing those with the group, just for reference? Because they're gonna be in the YouTube video anyway, but I think it's easier to copy paste if someone wants to understand more about a certain component. He can easily copy paste it. So yeah, that's
Well, no, there's like millions of sheets.
Yeah,
So
that's true.
basically, whatever component that you're looking at, just plug the name of that component in, do a Google search,
Yeah,
and
that's
say
true.
data sheet, and then it
Yeah.
will bring you directly to the manufacturer. And also make sure that you're going to the manufacturer specifically when it comes into digital components. But any component, like I say, even the triode, who's the manufacturer, and then just do a Google search, data sheet, and it'll all pop up for you.
No, I mean the PowerPoint that you showed us in the beginning of the lecture, that one.
Oh, the PowerPoint.
Yeah,
Yeah.
yeah.
So how can I upload that to you?
You could send it to me however you like, either on email or WhatsApp or Discord, and then I'll share it to the group.
Oh, yeah. Okay. Yeah, I could do that. No
Perfect,
problem.
perfect,
Easy.
perfect. Awesome. In the messages, people are thanking you. If you would like to take a look at that, you can see that.
Yes, I see that.
Saying, I do hope you come back for another session regarding protocols. FCC ID also really helps. Thank you for the lecture. Yeah, Professor, thank you very much once again for your time, and I'll be uploading
So
it.
hopefully this equates to me getting a couple beers when I come to the Netherlands.
Definitely, definitely. I hope I hope you come. I hope you come when we have an event going on.
Oh, that'd be wonderful.
That'd be amazing, of course, because then we'd have like 60, 70 members all in the same place. Then everything is definitely covered, and after that, people will usually go to a bar or something. So you can definitely hang out with us there. So that would be
Oh,
definitely
that's a
cool.
nice setup.
Yeah, that's a good
I
setup.
see in
Huh?
the comments. That's a nice setup there in the comments.
Yeah, is that at the Hackerspace Psychic?
Nice.
That's awesome.
Yeah, very good. Well, thank you very much. It was a pleasure doing
Yeah,
this for you.
pleasure was
And
ours.
I wish all of you a good evening.
Thank you very much, Professor. Have a great evening. I'll send you the link for the uploaded video.
Very good. Thank you
Thank
much.
you.
Bye-bye.
Have a nice evening. Bye bye.